Welcome back. In this video, I'll be solving Leetcode problem 763 partition labels. You're given a string S. We want to partition the string into as many parts as possible so that each letter appears in at most one part. For example, the string A, B, A, B, C, C can be partitioned into A, B, A, B, C, C. Okay, so we need to partition it validly. Note that the partition is done so that after concatenating all the parts in order, the result on string should be S. The size of these parts. This is all A's and whatever, other letters, C's and so on. Okay, this doesn't seem that crazy. Big acceptance rate, poor median, I would say. But essentially what we want to do, we want to count all the letters. So let's do that, count collections dot counter of us, and I want to have out, and I want to have I want to have elements, but in range. Line of S. So I'll call it here elements. So elements, it's not this, it will be set. This will track the elements in the current partition, or let's call it partition. So first I append to partition dot append dot add s of I, and I want count of s of I to be minus equal 1. But if s of I not in partition, then I want to add it. Each time I want to subtract, I'll do it like this. And then I want to go for each. Maybe I should have taken a look. Yeah, constraints are easy in this one. So for letter in partition, so I'll have a flag that's equal to true if count of L is not equal 0. I need to have flag false. So this will go through all elements. And if there's yeah, if there's something I will flag, I will remove my flag that it's good. And if it's good, let's make the let's like complete the partition, and I complete partition by, so if flag, then out dot append out dot append, so I have to have I minus start plus 1, something like this. And then I have to do start is equal to I plus 1. Start is I plus 1, and partition is equal to set, empty set. So start is increased, and then I just have to check will this do the last one also? Well, it should. It should, yeah. I think it should, so just return out. I'm not sure, but I think it should, and yeah, it seems it does the last one. That seems it. Let's try submit, and it works. Yippee. Seems not so efficient for whatever reason. Could have done better. I could have done better. Yeah, I could have done better, because if we're like, what would be complexity of this? Complexity of this would be, in worst case, if I think it's still log n. It's still often, but let's write it down. Complex. So I go through each I. Well, it's not n squared for sure. I'm not sure how to often, I would say, but it's often squared. Whoa, not nice, but it works. Yeah, seems often squared. Space complexity of yeah. Well, this idea is kind of bad. Essentially, what we could improve on, so if we have, let's say, so if we have A here, then I know that everything up until here needs to be included. And yeah, I think I'll leave it for another video. I think I have an idea. I'll just maybe give a hint. Imagine that we have a count, but we also have the last occurrence of each letter, some kind of dictionary that tracks the last occurrence of each letter. So for each one, we could, when we add it to partition, check what's the current. Yeah, I'll not finish what I was trying to say, but yeah, I think solution with that approach is pretty self-explanatory. Okay, that's it for this one. I'll probably make another one when I have time for this, and yeah, see you in the next one, guys.